Cool. My name's Alec. I'm an Android developer on Cash App, and I'm going to be talking about dynamic features today. It's pretty late in the day, so people might be kind of tired. I'm going to do my best to keep things interesting, but a lot of this stuff is like pretty weird too, and I'm not going to lie, some of it I don't even understand what's really going on. So if things get a little bit difficult, I'll try and keep things together and stick to my agenda. But yeah, so the plan for today, I'm going to get started and talk a little bit about dynamic features from an intro perspective. I'm not going to go too much into it because I think there are actually a lot of good resources on learning dynamic features. I'm really just going to drill into two specific parts. One is its effect on modularization, and then the other is how we're going to be applying it on Cash App. So yeah, that's the agenda. We'll get started. I'll talk about the history of Cash App and what our modularization has looked like. I think this will be really relevant as I start talking about dynamic features and how we kind of want to apply it. An approach that we're going to try and take, which is essentially starting fresh by using dynamic features. And then finally, we'll go into the implementation of dynamic features and some of the gotchas that we found. Because we're using it to a pretty crazy extent, some of the things that we've been discovering have been interesting, and so I think it'll be worth documenting those too. Before I get into it too, one thing I want to say is there's a lot of prior art here, things people have been talking about with dynamic features that I'm going to try not to repeat, but these are also just really useful resources if you're getting started with them. So when it was first announced at I/O, Florina and Yigit gave a really great talk introducing it, as well as just general modularization ideas. As part of that talk, they actually did discuss this idea that modularization is going to look really different for your app. It really depends on what your customers need, and how you want to use something like dynamic features should be influenced by that. So this is kind of going to be a follow-up to that in that we're going to talk very specifically about Cash App, how our modularization has looked, and how we're going to apply dynamic features to it. But another one of these by Leo Chu, who works on the Line app, he has a YouTube presentation talking about their approach to dynamic features. And this talk feels very similar to that one. If you were to watch them side by side, a lot of things would be very identical, but we're taking different approaches to it. So I want to present that too, because if you listen to this talk and you're interested in dynamic features, but not in how I'm suggesting you could use it, that is another great talk for another way to potentially use dynamic features. And then finally, Plaid underwent a migration recently where they started to use dynamic features. This is an open source app that Google makes. And they wrote an entire blog series on how they apply dynamic features to Plaid, and that actually did include a lot of the internals and gotchas that you might find. So some of those I'll repeat, not too much, but if you're more interested, I would go there. And then finally, a lot of the code that I'll be referencing is this thing called Box App. That's essentially just the playground I created to work with dynamic features, and you can find all that code on GitHub. So the first thing I want to do is actually go into how dynamic features will get loaded onto a device. So what we're looking at here is what an app bundle looks like, the AAB format. And an important thing to note here is you cannot use dynamic features unless you are already an app bundle. It got mentioned earlier today, but this is going to be required. You're probably already doing this, but if not, this is a prerequisite for it. The thing I want to highlight here is actually what dynamic features look like inside of an app bundle, and I've highlighted both the base app as well as the dynamic feature because they are mirrors of each other. What's happening behind the scenes is you have multiple APKs that are getting shipped, and then they're getting merged at runtime in the app. They can also get merged at compile time. There's different ways, and we'll talk about how things are fused together. But this is a core concept of dynamic features. We're literally taking our app and splitting it into multiple APKs, where 10 years ago it would only be a single APK, and there was no way around that. So that's the side of dynamic features that influences the actual thing going into the Play Store. There's also the side of it that affects your Gradle modularization. So you're probably used to this sort of modularization in your app, where you have a core app module that sits at the top, and then a bunch of feature modules that it depends on. With dynamic features, we're actually inverting this. So the way it works is that a dynamic feature module is capable of depending on the app module. And so the app module still has a reference to it. We'll see that later. But in general, it's entirely decoupled. It's possible that the app can compile without a dynamic feature loaded into it. So if you go into Gradle and you want to start implementing this, really the only thing you have to do in the dynamic feature module is use the dynamic feature Gradle plugin. Also, I'm very intentionally not using the string artifacts for these things, because one of the things you need to do in dynamic features is make heavy usage of a version catalog. If you have dynamic features using different versions of a Gradle plugin or a library, that can cause really big issues at runtime. And so you should just be using version catalogs anyways, but this is a good forcing function. The actual artifact for it is just like com.android.dynamic feature. It's not too surprising. And then, of course, the thing that's really interesting here is that you can depend on the app. The second piece of this that you have to do in the feature module is add some information into the manifest about how this is actually going to be distributed. In our case, this feature is just going to be at install time. So this isn't really taking advantage of a lot of the cool things with dynamic features. When you go to install the app from the Play Store, it's just also going to install this dynamic feature. In the app module, you have the opposite side of things, where this is just a normal COM Android application Gradle plugin, but now you reference the dynamic features that can be loaded as just an array of strings. The big thing to call out here is that we do still have a dependency on the features through the feature strings, but the strings aren't code, so you don't have like an explicit code dependency anywhere. And the interesting thing about this is that you can just eliminate that dependency entirely, and the app is still going to be compilable. If we go back to the other way that we were doing things, where you would depend on the library, it would not be possible if you just removed that dependency from your Gradle configuration for that to compile. That's kind of with an asterisk, because if you're using reflection or something, then yes, it would compile. But I suspect we're not doing that. The reality is with dynamic features, you're forced into this kind of situation. You have to be, because the app has to be installable without that dynamic feature. So you're also creating this decoupling where there's not going to be any code references to the feature from your app module. OK, so that's a very simple intro of dynamic features. There's lots of other stuff that you can find out. But the next thing I want to highlight is when you actually might want to start using these. The first one is probably pretty obvious. Because we're able to fragment the application itself, you're able to install a much smaller version of it onto phones and potentially defer things that never need to be installed for specific users. It's also possible to uninstall dynamic features, which is pretty cool. So if you just want to conserve the amount of space that's being used on the phone, that's an option that you get with dynamic features. Regionalization is a big one. I showed in that XML file the way that you could configure when that thing gets installed. You can also place conditions on that, so you could say only install in specific regions. And so now, all of a sudden, you have a new way of potentially changing how the app is going to be installed depending on where the user is. And then finally, and this is going to be the one that's probably the most relevant for Cache, is a huge team. On Cache, we now have 70 Android developers working on that team. And so a lot of the things that we run into now is actually just the clarity of our code base. How do you know who works where? Where do the boundaries of ownership lie? Those sorts of things. I think dynamic features, one of the things that they provide is this very, very intense clarity around this set of features. Because it's completely decoupled from other features as well as the app, it's very easy to draw a line around that and say who's going to be owning this, and potentially that's the only thing that they need to work in. So those are sort of the main reasons. The huge team one is the big one for Cache that we're going to be talking a lot about. Before we go into it, though, I actually want to talk about Cache App's history and sort of archive what our modularization has looked at over the years. And if you're not at our size, if you're not a 70-person app, this will probably be the most relevant part of the actual talk, where I talk about depending on where you are at in your app's lifecycle, it might be worth investing in certain types of modularization. Because in general, we're pretty happy with how we modularized and how things worked out. So I'll go out over time, and we'll just look at the code base structure. I'll use a very simple circles and lines diagrams of what our modules look like. And we'll track it over time, all the way back to where I could find our first internal release, which was 2016. We had Cache much before this, but this is when we started publishing it internally for people to download. So this is where we're going to start our journey. So we're going through 2016. About halfway through, we extracted our first module called Keypad, and I genuinely can't remember why we did this. So we'll move on to the next one. Towards the fall of 2016 was when we extracted another module. This one was Wire. This is just some additional stuff that we did to the Wire compiler. This one did make sense because Wire is a compiler, and it's getting applied to the app module. And therefore, the code for it cannot live in the app module. So it's just some extra stuff that we were doing on Wire that had to live outside of the app module. And then towards the end of 2016, we had another module introduced for Protos. This is kind of a similar thing. The Protos stuff had its own life cycle. It looked very different from the app module. It made sense for that to live outside of that. The thing I want to call out here, we're not really modularizing for any reason other than we have to at this point. In the first year of it, things were going fine, and modularization was not a needed part of our setup. OK, and then the next release. At this time, we weren't doing 2-week release cadences, so this was 4 or 5 months after that. This is when we really started to invest a lot in modularization. There isn't a ton of like coherence to how we were doing it. I'll sum it up, I think, in this way. This is how we were sort of modularizing at the time. You have the different domains that we separated into their own modules. And this was so that things that were like entirely unrelated could compile parallel to one another. So your network, your DB, those were like the two main ones that we had kind of split out. But we also started to create all of these UI utilities, as well as sample apps that would be built on top of them. And the purpose of those sample apps was essentially a much faster iteration loop for us if we wanted to just work on a widget. You don't need to load up the whole app. If you saw J-Rod's talk earlier about paparazzi, paparazzi essentially obviated the need for these sample apps, but this was like our early way of doing it. It also became a thing that we could give to our designers. Again, something that paparazzi does a much better job of. But yeah, the important thing here is that what we were focusing on at this point was just extracting domains out and having them in their own modules. And the goal here is really just to increase the amount that can be compiled in parallel. Oh, yeah, I should also mention, I have this like little legend at the bottom, and part of it was implementation or API dependencies. Those will come in later. At this point in time, we're in 2017. We actually don't even have those. It's just all compile dependencies pretty much. There were like compile only and provided, but in terms of Gradle, like it doesn't really matter for this part of the presentation. Like everything was just depending on each other. OK, so we'll keep going. And this is the next step that we took. This one was less about modularization and more about a separation of concerns. So this is the point at which we started to split out our business logic into its own layer called presenters. Those presenters typically were built on top of these like backends, stores, or we use the term manager all over the place, which is probably not a great term. But like essentially these things that would just like condense your DB logic, API logic, and do like certain backend operations that then the presenters would talk to. The idea was really just like separating out the UI from the business logic. We still follow this pattern today. There's going to be a talk right after this one from Benoit talking specifically about our Android app architecture, so I won't go too much into it. But yeah, this was the next major thing that we started to modularize out. So I'm condensing a lot. At this point, we're at 40 modules. This is around a year and a half after we started tracking. And we'll keep going. So we're in 2018 now. Things are still not changing too drastically. You can see our app size is like doubled at this point. And actually, I should call out to the app size that we see up there. It's not the actual app size of the Play Store. If I go into the Play Store and check it, it's typically a lot smaller than what you see there. This is something that's going to be like not affected by R8. We're just using it for internal releases. Also, things like app bundles in the future made the size of the app that we were distributing internally much larger than the size of the app that you would actually install on your phone. So though the app size is kind of like representative of our app getting bigger, it is not accurate as to like what the Play Store app size is going to be. But anyways, OK, we're now in 2019. At the beginning of 2019, our release 243, and this is the next major step that we started to take in modularization. And this was starting to modularize by feature verticals. So in this case, it was investing, which was the first one that we took out. And the thing to note here is that the structure inside of investing is the exact same as the structure we had for app previously. It still has like presenters, backend, API, DB. All of those things now are just investing specific. So we are still modularizing by horizontal. We're just now also modularizing by vertical. So we've just started to extract some of those things out into a feature vertical. Something I really want to call out here, though, is how we've changed the way that our app compiles. Gradle is waterfall, and pretty much any build system is going to be. So the only way to compile things is one at a time from the bottom up. When things are at the same layer horizontally, they can be done in parallel. But then anything that depends on them needs both of them to compile. So before, where app just depended on presenters, which depended on backend, in order for app to compile, it needs to wait for all of investing to also compile. And this isn't very parallelizable. Essentially, all of investing is going to compile at the same time as the rest of our presenters. But investing has its own very long tree. So at the time, this wasn't a big deal, but this is something to be aware of. And as we started like increasing the complexity of our app, this became something that we wanted to address. So this was the next thing we introduced, another like stage in our modularization, which was starting to extract out the APIs from the implementations of some of these modules. The reason that you do this is because you clean up that compilation waterfall effect, where now instead of having to rely on compiling all of backend, which itself has its own dependencies, all you have to compile in order to compile investing is the things that it relies on in terms of its APIs. The app module is the thing that's going to be hooking up the implementation into investing. So you can run investing on its own, but maybe it can't use some of the core services. But because it's separated out in this way, you no longer have that effect where things need to compile one at a time. It's much more parallelizable. And those API modules, since they're typically just a bunch of interfaces, are going to compile very quickly. This style of modularizing we really liked, so it started to pick up a little bit more in I guess this was 2019, March. We started to extract out other features into this style. So this has been a year and a half since the last time we checked in, and now we're at 80 modules. So it doubled in a year, and then it doubled again in about another year. And we get to watch as the numbers go up a little bit more. This part of the presentation is accurate numbers, and it's all of the releases that we actually have. And so we're just kind of like cycling through them. Another 4 months later, this time it's doubled. So you can see we're starting to pick up the actual rate that we're adding modules to our graph at an exponential rate. This one is 2 months after that time. We once again doubled the amount of these feature. And keep in mind, this isn't just adding 4 extra modules. This is adding 4 new graphs of modules every single time we do this. So you can imagine the number of modules we're getting to is pretty big. Also, while this is exponentially increasing, some of these modules, which didn't modularize well into the specific feature verticals, were also exponentially increasing in size. Protos is the biggest one of these. So a lot of the different feature verticals that we had, their protos were still in a single module. And as that was increasing, it became a new bottleneck. We could probably give an entire talk on how we solved this problem, but essentially we took our protos out of this repo and compiled them elsewhere, so that when you wanted to do a clean build or incremental build on your machine, it had already been built, all of the protos that you need. So we have more feature modules popping in there. We're getting close to the beginning of the pandemic, I think. It's 2020 now. Yeah, still more feature modules. So at this point, we're at 200. This time, it's been less than a year since the last time we checked in. We were in 80 modules, so we've now doubled again. I think from that time we were 40 modules. It's been about a year and a half to 2 years. So you can imagine things are increasing pretty exponentially here. And we'll see how quickly this one goes. I think there's actually, as we're going through the pandemic, there was not a major change in how we started to modularize Cash App. In general, this strategy has worked extremely well for us. Even though this graph is very complicated, the thing I want to draw attention to is that it's all very parallel. A lot of these things don't depend on each other. So even though we're increasing the horizontal size of the number of modules we have, with things like the build cache, it's actually all still very capable of compiling quickly. Yeah, I think I just got upset at one point at how big it was, so I just shrunk the size of the whole graph. But then the process of shrinking it was taking a lot of time, so I was like, it's small enough. And so now it's at this size, and we keep tracking it. We're almost, we're in 2022 now. The app's getting to 80 megabytes. We have almost 60,000 commits. And yeah, this is the most recent one that I tracked. This is from, I guess, a couple weeks ago. We're now at 800 modules. Last time we checked in was 200 at the beginning of the pandemic. So a 4x increase. App size has been pretty exponential. Again, the thing I want to call out here is there's actually lots of random drops or points of inconsistency in here. We've benefited a lot from just general tooling and improvements that are being made in the Android ecosystem. We haven't had to do a whole lot to reduce our app size. And as I mentioned, the Play Store app size for Cache now, if I check, it says it's between 20 to 30 megabytes, depending on the device it's installed into. So this 80 number is much larger than it actually is. But the reality is still there. Our size is increasing somewhat exponentially, although it hasn't become a major concern yet. The commits one is much more monotonic. This is easier to look at. There's a confusing point that drops down somewhere in 2021, which I don't quite understand. There's also something I'm very proud of, where you can see right around Christmas every year, it just flatlines, except for the year 2019, and some people will know that's when we worked on Bitcoin. That was great. So yeah, this is one of those things that I think it's really representative of the exponential curve that most code bases that are going through this sort of process will observe. But yeah, our build times, I don't have a great graph for that. If you saw J-Rod's presentation, he showed Gradle Enterprise, which is where we can kind of track that. We've only started using that about in the last year. But even as we've undergone this growth in that year, our build times haven't drastically improved because of things like the build cache. So you might notice that this is not a picture of 800 modules. We actually have a tool that we can use to generate one of these graphs. It has the bubbles and the lines between them. Like 5 years ago, it was very useful for being able to see this and like identify where there were issues with it. I decided to run this recently with the 800 module version just to see how things look. So everyone get ready. This is my favorite slide. Yeah, it looks like it's out of a horror movie to me. Like this is like some terrifying anthill or something. You can still see any of the like green or red things are the modules. They do actually have text inside of them that says which module it is, but you'd have to zoom in like 100 times to find it. And yeah, there's tons of dependencies going everywhere. Again, the complexity of this thing is purely at like this level where you're looking at it and it's very hard to understand what's going on. The complexity is not in things like the build time, which is great. A lot of this stuff is like really well parallelized, and again, stuff like a build cache is making this easy. It used to be much more of a problem with Gradle configuration. Typically, when you're like getting to this number of modules, that actually becomes the big thing. We had 2-minute configuration phases up until we started using the configuration cache. So now that that's introduced, that's another thing that's been really helpful. So yeah, what's the actual problem here? Because again, if like our build times aren't really that much worse, our app size isn't like enormous, and we're not regionalizing like super heavy, what's the thing that we want to actually solve here? One of the ones that's very tangible is just the IDE is slow. At this point, with this many modules and this much code, it gets really hard to load things. And just like loading the project for the first time can take an hour as it's like downloading sources. We generally just trust our modularization strategy. There's nothing really enforcing this. You could use stuff like convention plugins to start to enforce better modularization. But in general, like, there's not a very easy way to tell if we're introducing new dependencies or transitive dependencies or breaking our builds in some way. And then for me personally, I find it just very confusing. It used to be very easy to reason about our build graph in a way that like I could identify parts of it that we needed to focus on making better. But nowadays, I look at that like 800 line graph, and like there's no way I can reasonably figure out a way to make our builds better. So yeah, when I look at this thing, I would say like in general, it just kind of makes me sad. I think it's very hard to feel like there's clarity around this, and that's sort of the thing that I wanted to solve. And this is where dynamic features can start to come in. The reason dynamic features are so cool is because it introduces this new way of having dependencies between modules. Before, where everything had to bubble up into the app module, now it's possible to have 2 entirely decoupled features. What's amazing about this is that in order to have those communicate with one another, you have to have very specific terms of engagement. You can't just have a Gradle dependency between these 2 features. And so, as I was saying with like our prior modularization strategy, there was nothing enforcing this. You will get build errors if you try and like modularize dynamic features in a way that won't actually work. Because again, they need to be able to be installed one at a time. So it's very, very difficult, and in fact, impossible to couple them together unless you do it very explicitly. So this is a strategy you could take. You could just start applying dynamic features up here, and then over time start to pull some of those feature verticals out into their own dynamic feature. This is the strategy that they took with the line app. So at this point, if you're like, yeah, this sounds really great, I'd like to do it, that would be the thing that I want you to go look at. But we're actually going to try something very crazy. And we're going to take our entire existing app and turn it into a dynamic feature and just pretend it doesn't exist. The reason I like this is because to me it feels like a fresh start. Essentially, we get back to that like day 0 state where we have a single app module, and now there's just all this other stuff that I can just turn my eyes off and I don't have to think about. This probably sounds too good to be true. That's because it is. Derek is laughing in the front row because he's the one trying this all right now. And we've already found lots of issues with it. We're still going to talk about it for a few reasons. I think if we can solve a lot of these, it's like a very exciting potential path to go down. But even if we can't, we're discovering a lot of things about dynamic features and what sorts of stuff that you can do with them. So first I'm going to talk about some of the gotchas that we've run into, some of the problems with this strategy. And then we're going to actually go into like how you would build in this world if you wanted to. The first one is daemon dependencies. As soon as we tried doing this, it's actually very easy to like do the setup where you have cache app be a dynamic feature, but you run it and it will fail with this error where it says that both the app and the app module package the same library, which makes sense because that's a single module. The thing that's going on here is that it has a daemon dependency, so app will depend on, well, 800 modules is how many. And then somewhere at the bottom, there's going to be a single module like Protos that might have 1 dependency. But because of all those daemon dependencies, it's registering the dependency multiple times, and it thinks that it's 2 separate dynamic features that are loading the same library. And this is something that you do actually have to avoid if you're using dynamic features. You can't have 2 separate features depend on the same library and ship separately. The reason you can't do that is because it wants to ship them as a whole binary, so you would end up with like 2 versions of OKIO, for example, shipping. What you have to do is instead have The app module will be the thing that bundles into OKIO, and then each feature can use them. So you can fix this by just disabling that task. Again, with the app module, in our case, Cash App, there's only a single dynamic feature. And so it's OK if it has this, like, if a single dependency is showing up multiple times in some of its transitive dependencies, it's only loading that one feature. So it's not actually loading it multiple times. There's just a bug in this task. A better prepared presenter would then point to a Google issue that you can go to. Gotcha 2 is manifest merging. So manifest merging in general is like this kind of magic thing that happens for existing, even without using dynamic features, where you can have multiple manifest files, but of course the thing getting delivered to the device needs to have just a single manifest file. So there's all of these tasks that happen just to like merge all of the different manifest files. For dynamic features, this becomes very complicated because you no longer have a single manifest file that's getting installed. You might have other manifest files coming in with a dynamic feature. So what happens when, again, we did this with Cash App, you get these very cryptic errors when it goes to install them and try to merge them at runtime. It goes off the screen, and it's really not that important to try and like read this thing and decipher what's going on. The key thing here is that you will encounter some of these errors where like certain things in the manifest won't work. And again, this is happening at runtime because it's creating multiple APKs, trying to install the base one and then the new one on top of it, and then it's failing. And so this is actually, I guess, like an addendum to that gotcha, which is that is only the case when you run from the IDE. If you run from the command line, instead of creating multiple APKs and then installing them at runtime, it will instead try to do the merge of those APKs during compile time. Typically, this is a lot better because that means you're getting errors that are a little bit easier to read. So that's kind of been the strategy that we've taken. You just do your compiles from the command line because there it's telling you which APK is failing, potentially like the line number in the manifest, although those can sometimes be wrong. In this case, the error has something to do with, metadata requires an Android value or Android resource attribute. So it gives you a little bit more information into like what's going on in the manifest that's wrong here. And as you dig into that manifest, the thing that we realized, and this is, again, going to be a part of manifest merging that's very difficult, it was a third-party SDK and the contribution to the manifest that they were making, which is something that's not even in your code base. Like if you were just searching your manifest files for things that would cause problems, you may not actually find them because some of the manifest merging might come from a third-party SDK. And that's what was happening with ours. There wasn't anything wrong with this manifest entry. We were able to get around it by just removing it for now. The reason that it was failing is because this manifest entry was referencing a resource. And resources are the next gotcha. These ones are typically a lot easier to debug, although when it has to do with manifest merging, that's when it becomes a problem. Sometimes you will just get these error messages about resources just not existing. I'm not sure why this is happening, but there is a way to get around it that's documented in the Plaid blog post, where you essentially need to have a resources file inside of the core application that declares some of the resources other manifest files are going to be using. So like in that third-party SDK case, it's likely that the actual proper fix for that is adding the resources that it needs in this resources file ahead of time. OK, so far, that's what we know really sucks. It's a lot of manifest merging, resource stuff, and then just general Gradle things that are difficult to work around. I'm now going to talk about how we are structuring this stuff and a little bit more of the architecture of dynamic features. This stuff will be applicable regardless of which way you start to do it. If you wanted to just like put dynamic features on top of your app, or if you wanted to do this crazy thing where you try and make the whole app a dynamic feature, these are all going to be different strategies that you can take to actually architect that. So let's go back to this diagram, the simple one that we have. And remember that Cash App there is actually 800 modules, but there's just this one dependency it has on the Box app. And we're going to start designing this thing. Box app in its Gradle file is going to look exactly like how we were setting things up. It just applies a normal Android application and declares the dynamic features it has. We do need some way for features to actually integrate into Box app. And so what we're going to do is just create some interface. It's arbitrary. It doesn't really matter. For your app, it will be whatever you need it to look like in order for some kind of like UI or integration to get into the core app. In our case, all we're doing is we're drawing a screen with a bunch of boxes. And so what we would like is for each feature to give us the box it would like to draw. And again, this is how that looks with some Compose UI. For each box feature, we just draw its tile inside of a box. Not very exciting. OK, we'll now go into Cash App and implement that feature so it starts drawing a box in Box app. This thing, the key thing here is that we're starting an activity that lives inside of the dynamic feature, so that's totally fine. We are using this navigator thing, which I'll point out is like, obviously this isn't how you should do things. We'll properly set this up later. But now that we have this set up, oh yeah, this is a very important part. So I kind of hid how we actually get a reference to these box features. As I had mentioned before, it is impossible to have any code dependencies on a dynamic feature. That is what makes this very interesting. There's like proper decoupling where you can't reference any code in a feature, but it has to hook up somehow. So how do you do it? With reflection. Boo! And you're probably thinking, that sucks. Isn't there a better way to do this? There is not. You have to use reflection. You can find some samples where they suggest using Surface Locator. I've used Surface Locator, which, again, is also just using reflection. But I've used Surface Locator, and it works. But I think that depending on how the dynamic features can get loaded, it doesn't play well with R8. It also might not be very efficient. So this is the recommended, and I think best way to do things is just to use reflection. So not great, but this is it. We have thought about ways to, because it all exists in the same code base, you can imagine making this reflection safer by like code generating some of this stuff. And so there's potential futures where dynamic features are a lot easier to do than this, but if you're doing it today, this is the way it happens. OK, and now we have our box app, and it works. That is a new separate application, and Cash App is just loading inside of it. You click its box, and it loads the Cash App activity. There's probably parts of the app I'm purposely not clicking through because they break. There's a reason that we haven't committed all this stuff yet. There's still things that we're working through. Again, we're finding more and more gotchas as we go through this, but it's an interesting way to sort of explore dynamic features. Now we're going to introduce a second feature because this is when dynamic feature starts to get really powerful. If it's just a single dependency and it's getting fused in, you might as well just keep it all as a single app. But the whole point of this is that we want to be able to have things live in parallel. So the second feature is also going to implement its own tile. And so it will show up on the screen same way. There's nothing interesting there, but something that we also oftentimes encounter in Cash App, and I think is like a very common scenario, is when you have two features that actually want to talk to one another. And for me, this is really the important part of modularization, where if everything was just properly decoupled, it would be very simple to modularize and think about like where teams should be working and contributing. And having those dependencies between features is actually where a lot of the breakdowns happen, and it becomes really hard to collaborate on code. So this is the thing I really want to dig into and how this would actually work with dynamic features. We're going to take that same approach we took to modularizing our backend, where we're instead just going to create an API module for that feature. And so that is going to be the only way you can talk to it. No one is able to depend on the dynamic feature module. They have to interface with only its API. And so we'll just create like some random API. It doesn't matter what it is. But we have our big box feature, the one that's separate from Cash App. And this is how other features are going to integrate with it. They just want to register some widget to show up in its activity. Unfortunately, this does not work. If you do this, if you have a library module that two dynamic features both want to depend on, it will break and tell you that it needs to be a dynamic feature module itself. This is because these things can be installed separately, and so who is actually responsible for downloading that thing? Are they both responsible for downloading that thing? The structure for figuring out how that gets downloaded is dynamic features. If it's just a library module, all that means is that both of them are going to include it, and that's when you would end up with runtime errors. And so this thing needs to be a dynamic feature module in order to have this kind of structure. Or because this is a very like primitive library, there's no reason this thing cannot just live a layer lower. So it is always included in Box App, regardless of which dynamic features are installed. You're not too worried about this thing because it doesn't have too many dependencies. It's not going to influence the APK size. So it's OK having that as a separate API live within Box App. And the other important thing to note here, too, is that there is a soft limit on how many dynamic features you can have. Around 50, it starts to become less performant. So this is actually a much better structure for it because you don't want to have so many dynamic features that you start to incur performance hits. OK, so the implementation of that API, again, this is just like the screen that the box feature is going to show. It's implementing that new thing that we created. And then it's just going to be able to display all of those widgets. The next interesting part of this thing is, again, we were using reflection before. How do we actually integrate this into Box App? How do we register it as the implementation of that interface? We're going to need something new inside of Box App. So I would propose an interface, something like this, some sort of feature registry, or something you can just both install services into and then listen to when that thing gets installed. I am not going to put the implementation of this thing up here because it is very weird. Those need to be reified types, which means it can't be on an interface. They have to be inline functions that are like extensions on top of it. In the slides, I have the implementation, so I'll hide that, and you can look at what it looks like. But essentially, this is the API that you want to be able to call. Essentially, like register me as the implementation of this interface. And then inside of Cash App, if you wanted to use the implementation, you would say, OK, when it gets installed, let me run some code. So again, this is what the implementation of that is going to look like. Also, we're starting to use DI here. But yeah, this is the important bit. We're saying that when the big box main screen gets installed, do some stuff. And in our case, we're just registering some code that's going to show up there. Now that we're starting to talk about dependencies, I do want to go over how dependencies will work in this. And we're going to start using Dagger more for it. So that place earlier where we had the singleton navigator, we're going to change that to be an injected navigator. What's important here is that box app is going to be the thing providing all of these dependencies, like the feature interfaces or registry, as well as the navigator and things that are needed there. So you will need some component that lives inside of box app that provides these. I don't know if this is the right way to create a Dagger graph for this. For whatever reason, I was on vacation and saved creating all of the Dagger slides to the last minute. And Dagger is a very, very hard thing to figure out last minute. So this works, but I'm not sure if this is exactly how you would do it. It's not that important. The important thing is that you probably have some way of creating an object graph in your app. You would just want to do the same thing in this module, the box one. Create it wherever you would normally create it, whether that's like the implementation of application, implementation of activity. And then this is really the core thing. Inside of the dynamic feature, it will probably have its own object graph. In Cash App, we have an object graph it's using with Dagger. You can specify a possible to create that object graph without also giving it the object graph of box app. So it'll fail at compile time, and you'll know that, OK, I need the other object graph in order to create this one. And so that's how you can facilitate that. And then all of the dependencies that box app is providing, your features can start to use. So that's easy. Again, if you already have an object graph, this is great. You just do this. It'll start to fail, and you'll know where you need to fix things. Other features might need an entry point, somewhere where you like create this object graph. So this is the last interface we're going to make, but this is essentially an interface that we're going to let any dynamic feature implement if they just want some kind of life cycle of like, OK, I exist now. Either like I exist at install time, or I got a deferred installation and now I'm here. And so this is the one we're going to take for big box. And so some of these things are going to start to piece together here. This thing that implements feature entry, when we call it start, it's going to create its object graph using the component passed to it from box app. And then it's going to start to like register all of those things it knows about. It's going to install the big box screen implementation, and then it's also going to like put the tile on box app screen. Now, we still need to do reflection somewhere, but the advantage of the strategy is that we only need to do it once. We just do it in that one place where we find out who implements the feature entry interface, and then call into it with the component of box app. So that's what we're doing here. We're saying like for every single feature, create a new instance of its feature entry, and then start it. This is also where you would start to change the entry point for your on-demand features. So right now, we're assuming they're all at install time. But of course, we might want to change that. So to do that, you go into the manifest. You change it from install time to on-demand. That means it will be a deferred installation you can do some other time. And then I'm just going to gloss over the split install manager stuff, because this is also well documented. But essentially, there's this API for downloading the code and then also listening to it. It uses the module name as the thing for like identifying what you want to download. So in this case, big box feature was the module name, so that's what we download. You can register a listener, and then in the callback for that listener, once it's been installed, that's instead when you would use reflection to the single code point and say, here's your object graph, get started, do whatever you want. OK, now we have this whole working thing where there's a separate feature now in addition to Cash App, just this big box feature. All it has is a single screen. But the really cool thing here is that it's able to render UI from another feature. So like that is my balance from Cash. And if Cash App wasn't installed, that widget wouldn't show up there. If the big box screen wasn't installed, Cash just wouldn't be providing that widget to anything. So you've created this system where like features can talk to one another, but they can still coexist without one of them being installed. And that's really the interesting thing here. We can use the same strategy that we just did for the feature APIs for any like core APIs. So in Cache, we have this thing called entity sync that you could extract down there. So if any features wanted to use the same core API, you would just follow the same strategy. What we would anticipate happening if we do this in Cache App is a lot of the current backend dependencies that exist within Cache App would start to move below this like new app layer. So we would start to prune different things out that need to get shared by a bunch of dynamic features, anything that's core. OK. When I set off on this mission, I wanted to talk about how it would help with big team size. And I think the really big key here is how it provides focus, both on the job and what you do, but then using the library focus from Dropbox, you're able to get a ton of superpowers with dynamic features. If you've never used Focus before, it's a Gradle plugin that's capable of shrinking down your settings Gradle file to only the modules that you're working with. And so you can tell it, like, I want to focus on just my presenters module, and it will unload all of the modules that are unrelated to presenters. And this will make your IDE faster and will make Gradle configuration faster, so potentially your builds as well. The reason that this is so cool with dynamic features is that traditionally Focus is a bottoms-up thing. When you're focusing on your presenters layer, and then everything above it is going away. But with dynamic features, because we've created these two diverging paths in the tree, you can focus on a single dynamic feature, and then the other one will just go away. So there's two places to do this if you wanted to be able to shrink down your working set to only the one feature you're doing. The first is in that app module where we had specified all the strings of dynamic features. You just get rid of the ones you don't care about. Then you would run Focus on the feature that you are working on. And now when you go to run the app, you will only see the features that you're working on. And maybe most importantly, when you're in the IDE, you will also only index and be able to work with that feature. So all of a sudden, you have this very small slice of the entire code base that you're working with, and you get a little bit more of that clarity and focus. And really, I think this is all this was meant to say. The goal here is really to get to a point where that big 800 module thing inside of Cache App is something that you could conceivably block out from your working set and still be able to work on Cache App. A lot of the stuff that we were trying to do with sample apps was trying to solve the same thing. Essentially, be able to run something that's a lot simpler, so you have a view of the world that's a lot easier to work with. So I think this is a potentially very cool way to get clarity. It's one option. We'll see if it works. But yeah, there's multiple different ways of using dynamic features, and I would encourage people to experiment with it. I think, if anything, the reason I wanted to give this talk was to hopefully get people interested in it and try their own things. And some of these gotchas that we're running into are, to me, all solvable problems. And so if we can just kind of figure them out, the amount of stuff you'll be able to do with dynamic features will be much greater. Thank you. That's all for me. That's my dog. It's his birthday today, so yay. Thank you.